Alright, so now we've been brought to this sensors list page. You can see at the top of the page here, again, it's saying that these sensors are the primary interface that we can use to send or forward telemetry or data into LimaCharlie. And we can see at the moment with our sample configuration setup, we have 3 sensors already created and deployed. But in the left navigation, you can see there's a ton of stuff for us to dive into, but I'll just touch on the most important concepts that you'll typically see with most EDR deployments. And if I just zoom out for a sec, we can see we have this online status for some of our agents. And so what I'm going to do is just change our filter here to click on the X here to take off our online is true condition. And when we do that, we're going to see a couple of more agents appear. And these are currently not online, but we do have telemetry collected from these agents that we can look into. And actually, if you just deployed LimaCharlie, you probably don't need to do this step because you can probably already see the IT01.corp.net sensor already listed here. It's just because I deployed my instance a couple weeks ago. And so in my case, it's no longer active and it's gone offline. And so I can see a demo sensor here called IT-01.corp.net. And so I'm going to click on this to open up the sensor. And so LimaCharlie has what we've come to know as agent-based EDR class telemetry. And so we have an actual binary or executable running on a system that is sending us events about that system in real time into our centralized EDR solution. And it captures all the things that we've talked about before, right? Like network activity, or processes being started and terminated, or registry modifications, or files being dropped, logs being written to. All these things that we've come to know and analyze as they all work together to paint the picture of what is happening on the system in real time. And so from this overview page, we can see a lot of metadata about our sensor. So we can see the host name that the sensor is running on. We can see the network or quarantine status. And so in this case, network access is allowed for the system. And we can see other things too, like the sensor ID for this agent or sensor. We can see the enrollment date here, so when the sensor was installed and connected to LimaCharlie, and get information about the platform itself, and so obviously in this case, Windows. And we can typically tag different endpoints or devices with EDR systems as well. And so this allows us to deploy certain policies or rules to a subset of systems within our network. And so it can be used for testing out different rules or policies, or separating devices based on operating system, or even their function within our organization, or the criticality of data that they process or store. And now let's head to the analytics section within the side menu. And so under analytics, we can see the actual number of events that we collected from the sensor in this graph visualization. And so obviously at this point, you would only have telemetry or data from today or whenever you install LimaCharlie. In my case, I actually installed the demo configuration a couple weeks ago. And so if I just hit week or month here, I can see all the events that were captured in this graph view. And typically in a real deployment, you would obviously have data and telemetry being collected every single day. And if you suddenly stop collecting data or see any stops in this graph, that would mean there's some sort of issue with your agent. Let's head over to detections. And so under detections, we can already see a number of detections from the telemetry that this sensor captured and LimaCharlie analyzed and flagged on. And if you don't see anything here, right, if you don't see any detections yet, you might need to give it some more time for the demo tenant and all of its data to deploy and collect. And so any of these detections here occur when any event on the system matches any pre-configured detection and response rules. And we can of course edit and create these detection and response rules ourselves, which we'll look at shortly. For example, as I start looking through these detections, it looks like we have a couple of detections from suspicious child processes that spawn from a browser. And so by clicking on the detection, we can get much more detail about it, all in this JSON format, which looks a little confusing at first, but is actually really easy to work with, especially when it comes to scripting or using APIs. And so we can see the actual time that the detection occurred. We can see the detection source, so where it's coming from, in this case our IT01.corp.net system. And we can see the category of the alert as well. And as we look through the JSON object of this detection, we can see the actual rule that's being triggered. And based on the author value, we can see that this is a predefined Soteria rule. And Soteria is a US-based MSSP that has written and managed a number of LimaCharlie's detection and response rules. And so based on the category of this rule, it looks like we had some sort of suspicious parent-child relationship spawning from an internet browser process. And so as I scroll down, we can see the parent object here. Specifically, from the command line value, it's pointing to iExplorer.exe. And we can further confirm this through the file path value as well. and this refers to the Internet Explorer web browser. And so we can see the parent process ID, along with the child process ID and the user that spawned the process. And so from first glance, this appears to be the legitimate Internet Explorer process. In fact, we could even take this hash value and double check it if we really wanted to. And so I'll just copy this value and head over to good old VirusTotal. And if I paste in this hash value, well, we can see that this is in fact a file distributed by Microsoft. And you can see we have no detections from any of these antivirus vendors. And it does in fact relate to iExplorer.exe. If we scroll back to the top here, well, we can get information about the child process itself. And so in this case, we can see the command line value, which looks to be running rundll32.exe. And we can confirm this through the file path value as well. And back in the original command line field for the process that we identified, we can see that the rundll32 process is executing a command involving wininet.dll. And so it is a little suspicious to see the Internet Explorer process spawning an executable, but it's not entirely out of the possibility. And so let's copy the hash value of this child process. And back on VirusTotal, we can do another search. And so again, this appears to be another clean file distributed and signed by Microsoft. We have no detections from any of our vendors. What I can also do is just Google the name of the executable. And sometimes this is a good technique if you want to find out more information about a binary that you're investigating, or if you want to know more about what an executable's purpose is on the system. And so we can see here that rundll32.exe is a standard and expected part of Windows that's used to run DLLs or dynamic link libraries. And so it doesn't mean that this finding is completely safe or benign, or that an attacker isn't abusing the legitimate binary in some way, but we can confirm that it's a known and signed and expected Microsoft binary. And now if we scroll down to the detection context section, we can see things like the description of the detection. And so as we've gathered, this detection fires off when a web browser process executes a suspicious child process, like anything related to shells or executables. We can look under the false positive section, which will give us information about legitimate use cases for this process to spawn, or scenarios that wouldn't be indicative of malicious activity. You can see some references listed here that include URLs for different articles or repositories that can give us additional information or resources about this detection. And under tags here, well, we can actually see some tags from the MITRE ATT&CK framework. We're going to talk much more about the MITRE ATT&CK framework in the threat intelligence section. But just know that these detections can have tags to clue us in on the type of finding that this is, or lead us down related research or correlation paths. And so to summarize this detection indicates that the Internet Explorer process spawned an instance of rundll32 to execute the wininet dynamic link library. And so at this point, we can't fully mark this detection off as a false positive. At least not yet, because we don't know all the information. And so we'd have to do a deeper dive and maybe look at some of the surrounding context around this user and their system. My immediate thoughts here are to try to get my hands on that wininet.dll file and look into what that dynamic link library is supposed to do, and at the very least try to extract the hash. We might need to query different logs from the SIM and look at things like incoming or outgoing connections, or even hop onto the endpoint ourselves and perform some of the live investigation steps we did previously and try to extract any signs of compromise. And so in this case, we obviously can't do that because this is a demo detection. But you can see how powerful an EDR-like system can be, in the sense that it brings all of this different information into a single pane of glass based on these behavior and heuristic-based detections. And no matter what EDR solution you end up using in the SOC, well, this is going to be the general process and the general experience. Right, so you're going to get detections or alerts within the EDR console. And these might be forwarded into the SIM itself, or listed out in some sort of incident response or ticket management system for different SOC analysts to pick up and work on. Or they might be forwarded as a webhook into something like Slack or an email inbox, so analysts are getting notifications about the alert. But no matter how the detections get to you, well, you'll be able to dig into them and look at the surrounding context and the different behavior. Right, so you know what processes are running, and what is the parent process? The hashes of the executables, or who is the user and what is the endpoint affected, or what IP addresses or ports were involved if it was a network connection. And some solutions might have more visual ways to display this through different graphs or process trees, Or you might be looking at structured data like JSON or other key value pairs. And so we also have this live feed section here. And this is kind of cool in theory, but not super practical. And since my specific agent is no longer active, I can't actually go into this section here. But this is actually going to pull back live events as they occur on the endpoint. And obviously this is going to be a ton of information overload. And so unless we're in the middle of an incident and we're trying to locate active connections or events as they're occurring live, well, we're better off using the timeline feature or the detections. And so speaking of timeline, this is a really important section because we should always be trying to rebuild and trace the timeline of events during an incident response and forensic scenario. And so of all of the different telemetry that we can collect with an EDR, the timeline is one of the most important data feeds that we have. And so by having all of this data and telemetry, we're able to reconstruct all of the events as they occurred chronologically on the endpoint, which gives us such a great advantage when it comes to detecting compromises. Because it's super important for us to understand all of the different things that led up to and happened after a particular event, so we can make the most informed decision about what happened or took place. And this is a snapshot of all of the events on the system as they occurred. But unlike the live feed, this view isn't automatically updated. But we can use the Fetch Latest Events button here if we needed to. And so you can see a number of events here on the system, obviously. And these contain different things like processes, so we can see process IDs or different command line values. We can see other events like network events or DNS or files. And so as our endpoints are conducting their normal operations, well, they're doing things under the hood. And we can capture all of that here, right? So we might see events related to network connectivity or file actions or directory actions. We might see memory or service actions or changes to the registry or mounted volumes. And this is exactly the type of visibility into our endpoints that we want to capture, because this is what is going to give us that context and help us make decisions about what is happening on the endpoint. And we can also filter for specific events here, which is really powerful and almost gives us mini SIM-like capabilities over this endpoint. And so we can jump around the timeline to show a specific time range here, or we can filter off of specific fields. And so if I click on this blue plus icon here, well, we could filter for specific destination IPs or command line values, or different DNS-related fields, or process IDs, or file paths, or even hash values as well. Just for example, I'm going to type in hash here. And we can see we have the event.hash filter. And so I can set this to is to equal a particular hash value. And from here, I can paste in the SHA-256 hash of the Internet Explorer binary that we identified earlier. And so if I just click on done here, well, you can see we're pulling back all of the different events in our timeline that relate to the Internet Explorer executable. And this is like super powerful when it comes to pivoting our investigation and hunting for evil. And so I can click on any of these events here. And again, we're going to get that JSON output containing all of the different information about this event. And in this case, of course, we can see the file path here is pointing to Internet Explorer. Under the hash value, well, this is where we're getting the match. In this case, we have a network connection event. We can see things like the destination IP address and the port. And so if we needed to, we could look into this IP address and perform different reputation checks and figure out where it's actually pointing to. And so by combining the features like an endpoint agent or sensor and using the timeline functionality, well, we've achieved one of the most important things we could as a SOC, and that's visibility. Because once we see what's happening in our environment and the different things a system's doing, well, we can then apply the security context around it. And we can start to answer questions like what's normal, or what is expected, and obviously what is abnormal, right? And so we can start building up that baseline. And that is essentially the whole purpose of a detection and response platform. And we could do a deeper dive here. But again, this is quite similar to what we're going to be doing in the SIM section, just at a larger or more holistic scale. And so feel free to play around with the timeline feature here. And so if we head back over to detections and try to find the same detection we were looking at, and with a detection opened, we can click on the View Event Timeline button right here, which will jump us right into the timeline to the exact event that triggered the detection rule. And so obviously, because of all the reasons we just went over, this is really useful for us as analysts because now we can see all of the different events that led up to and immediately followed that detection. And so I'm going to click on Back to Sensors here at the top. And from here, let's head down to Automations. where we can do a number of really interesting things, like building out our detection and response rules, or even Yara rules, which we'll touch on later in the course. But basically, Yara can scan for malware by checking files and network traffic for different patterns or scripts or signatures that indicate the presence of known malware. But let's click on the DNR rules section. And this refers to our detection and response rules, which really powers the EDR functionality we're trying to achieve with LimaCharlie. And so you can see within our default installation here, we have around 2,000 rules that have been pre-configured. And we can edit and create our own rules as needed. Say, for example, if we had a specific scenario or identified a specific indicator of compromise unique to our environment. And each rule defined here has two different descriptors written in YAML format. And so there's one that describes what to detect, right? The different conditions of the detection rule. And another one that describes how to respond. For example, I'm just going to search here for reg_add_run. And we should see this rule appear called process creation with registry add run key. And so let's open this up by clicking on the rule. And so from here, we can get different metadata about the rule itself. And so we can see the author, in this case, it's a Sigma rule. We can see when it was created and updated, whether it's enabled or not, and different tags that relate to the rule. And so again, we're seeing some references to the MITRE ATT&CK framework. We're also seeing that this is a Sigma rule, and the rule is related to a persistence mechanism. And so to view the content of the rule, well, we have this link here that opens us up to a GitHub repository. And so within the context of this rule, well, we can see that this rule's purpose is to detect suspicious command line registry modifications using the reg.exe tool that add a value to the run key, which, as we looked at earlier with Windows, could be a persistence or backdoor attempt. And so we have a detect and response section, as we just mentioned. And the detect section contains all of the different conditions that match the rule. And so we can see that the rule is going to trigger when a new process is created, or with existing processes as well, that match this specific condition. And the conditions are going to match a specific set of substrings. Specifically, we can see the reg value here, which refers to the reg or registry command. We can see a reference to the add keyword here, which when paired with reg, is the reg add command, which is used to add or modify a registry key. And lastly, we can see reference to the registry value pointing to a run key. Okay, let's head back to our demo client. And if we click on Outputs here in the navigation, this is where we can create some automated workflows in order to integrate the data and analysis, so things like events and detections, from LimaCharlie into other tools, which is quite common in the SOC. And so we might configure our EDR to pipe any critical or high alerts into a Slack channel, for example, so analysts can get real-time notifications when things need immediate attention. Or we can also configure things like email notifications as well. And so if I click on Add Output here, well, we can see a number of different conditions or output streams that we want to output. And we can see all of these different destinations that have been pre-configured within LimaCharlie. And so we could send notifications through a Slack channel, or over email with SMTP, or through the syslog protocol, or basically anywhere using a webhook. And so we're not going to set up any of these here, but these are output features that you'll commonly see in EDR tools. And so lastly here, if we head over to the add-on section in the top right of the navigation, well, this is the add-on marketplace within LimaCharlie, and this is where we can add in new integrations, or tools, or different solutions that can pair with LimaCharlie to give us additional functionality or data enrichment, and really start building up those Lego blocks to custom tailor the solution to our organization. And so, for example, we have this binary library extension here, which can enrich all of our data with additional metadata about any executable binaries observed with our endpoint's telemetry. And we have some other really cool things here, like integrations with Sigma, or with Velociraptor, which is another great DFIR tool. At the bottom here, we have an integration that we can include for VirusTotal. And in this case, it's a lot like the VirusTotal integration that we looked at within PhishTool. And so if we register an API key within VirusTotal, well, we can automatically query files or hashes within our environment from events and get those real-time results and reputation checks directly from VirusTotal's database. And so this is just another example of some of the enrichment we can get, and again, is a very common thing you'll see integrated within different EDR tools. And so I know that there was a lot that we covered here, and we did go through it kind of fast. I just wanted to showcase the main sections of this tool and the main methodologies around using it. And so again, we don't need to become experts at LimaCharlie specifically, or even any EDR tool for that matter. I just wanted to showcase the common features that you'll come across when you start working with an endpoint detection and response solution within your organization. And again, this is a fantastic free tool that allows us to do just that. And so in the next lesson, we're going to configure our own endpoint sensor or agent onto our Windows machine and generate some real detections. And so this will be a lot of fun, and so I'll see you in the next lesson.